Each year, scientists, researchers, and everyday people make incredible discoveries, helping us to better understand the world around us. So today, here at Unexplained Mysteries, we'll be taking a look at interesting discoveries. Large Hadron Collider breaks proton record. The Large Hadron Collider has fascinated scientists as the world's largest and most powerful particle accelerator since its inception in 2008. This mammoth facility is run by the European Council for Nuclear Research near Geneva, Switzerland, as a part of its accelerator complex. Accelerators allow researchers to propel charged particles at nearly the speed of light against objects or other particles to study how the beyond microscopic particles of our world interact to create the fabric of our everyday lives. The Large Hadron Collider is currently the most powerful accelerator in the world, meaning that it can accelerate particles at speeds beyond any other accelerator, and it just got an even bigger upgrade. Already a powerhouse for particle acceleration, the Large Hadron Collider was shut down for 3 years as the CERN team worked to implement several new cutting-edge improvements for the machine and facility to allow it to become even more powerful. Although it held the title of the largest and most powerful particle accelerator anywhere in the world, these upgrades allowed it to beat its own record and generate beams of protons at a higher energy than ever before. CERN announced this incredible news in a tweet saying, "Today, the 2 LHC pilot beams of protons were accelerated for the first time to the record energy of 6.8 TeV per beam. After restarting LHC, this operation is part of the activities to recommission the machine in preparation of LHC Run 3, planned for the summer of 2022. Previously, the highest amount of proton beam energy produced by the particle accelerator was 6.8 tera-electron volts. And while that may not seem like much of an improvement to some, when it comes to the kinetic energy of a single proton, one of the smallest units of the matter that makes up our world, it's a mind-boggling amount full of the potential for new discoveries. The particles that are manipulated in accelerators, such as the Large Hadron Collider, are understandably difficult to study because they are so infinitely small. When the particles collide with each other, they form larger particles, such as the Higgs boson. But these secondary larger particles only last for less than 1 second and promptly decay into lighter, smaller particles, which also immediately begin to decay. Measuring these particles requires the use of a detector, as they cannot be directly observed by the naked eye. Developing powerful accelerators, such as the Large Hadron Collider, allows researchers to have an even more detailed view of the infinitely small pieces that make up our universe. Specifically, the Large Hadron Collider facility and team are interested in using the knowledge ascertained from these experiments to probe the unknowns of dark matter and the complicated intricacies of particle physics. Researchers hope that this new phase of unveiling the added power and capabilities of the Large Hadron Collider will set the stage for an age of groundbreaking research and discoveries about the particles, like protons, that make up our world at the smallest level. Scientists sent a huge underwater space telescope into Lake Baikal. In southern Siberia lies a freezing lake by the name of Lake Baikal. Russian, Czech, Polish, Slovakian, and German scientists collaborated, developing and sending a colossal specialized telescope into its icy chasms in hopes of searching for rare and unusual particles, including the universe's most tiny, elusive particle, neutrinos. The telescope in question is the Baikal GVD and was created with searching for neutrinos in mind. Neutrinos themselves are tiny particles that are subatomic and almost have no mass at all. They are not electrically charged. Neutrinos can technically be found anywhere, not necessarily exclusively at the bottom of mystic Siberian lakes. However, their immensely small size makes it extremely difficult to detect them under normal circumstances. Lake Baikal is 1,700 meters deep and is presently known to be the Earth's deepest body of landlocked water. Lake Baikal is full of fresh water, covered by a sheet of ice which will help keep out any solar or cosmic interference with the neutrino detectors, which are commonly built underneath the ground in order to avoid said interference. As such, Lake Baikal can be a location of scientific note, when it comes to researching and finding these tiny particles. The neutrino detectors were drilled through the ice 4 kilometers away from the shore of Lake Baikal, and the scientists proceeded to place the components of Baikal GVD 1,310 meters into the freezing icy lake. Glass spheres were attached to the telescope. These glass spheres are photomultiplier tubes that can see the specific spectrum of light produced when a neutrino is in the lake water. This device is dubbed the Cherenkov light after Pavel Cherenkov, a Soviet physicist. Baikal GVD is a truly huge telescope, the second largest neutrino detector ever created. The first is the IceCube's South Pole Neutrino Observatory, searching for neutrinos in Antarctica. The IceCube detects roughly 275 neutrinos a day in the atmosphere. Someday, the scientists involved hope to expand the size of Baikal GVD. Among the scientists was Dmitry Naumov and Ber Shaboynov, both of the Joint Institute for Nuclear Research. Shaboynov stated about the lake, "Of course, Lake Baikal is the only lake where you can deploy a neutrino telescope because of its depth. Fresh water is also important, water clarity too, and the fact that there is ice cover for 2 to 2.5 months is also very important." Earliest inhabitants of the Amazon created thousands of artificial forest islands. Communities in the Amazon left their mark on the landscape 8,000 years earlier than previously thought. A 2020 study from the University of Bern suggested that 10,850 years ago, people inhabiting the Llanos de Moxos region of North Bolivia altered the landscape, which ultimately led to the formation of 4,700 forest islands of anthropogenic origin. These islands seemed to rest upon large mounds of food waste. These mounds were, of course, rich in nutrients, which made them the perfect site for thriving forests in the middle of an often flooded savanna. Researchers believe that communities in Llanos de Moxos were able to cultivate manioc and squash. The idea that this domestication inspired the islands is supported by the consistently circle-shaped tree formations, which are unlikely to occur naturally. The raised islands would help communities circumvent the seasonal flooding that threatens crops. To confirm the artificial tree island theory, researchers mapped the islands using remote sensing. 6,643 islands were mapped, but only 4,700 remain today. The team conducted excavations at 81 sites and analysed dozens of radiocarbon dates and phytolith samples. Phytoliths are microscopic silica structures from plants that are often preserved in tropical forests. These tests confirmed the presence of domesticated plants in the region. The idea that the southwest Amazon was a hub for early plant domestication has been popular among the scientific community because manioc and squash are genetically like the wild plants of the area. It is difficult for researchers to find evidence of plant domestication in places like the Amazon, where the climate affects organic materials. However, with the new study, we finally have confirmation that the southwest Amazon was indeed one of the earliest sites of plant domestication. Previously, only 4 areas were identified as ancient plant domestication hubs. Now, scientists must add a 5th location to that list. California scientists discover new type of earthquake. Until 2016, when scientists uncovered a new, more destructive type of earthquake, we thought we understood the mechanics behind the natural disaster. We believed that earthquakes occurred in the top half of the planet's crust, as a result of friction built up over time as the tectonic plates rub against one another. This is true for most earthquake events, and isn't inaccurate, though it appears that worse fates could be on the horizon. A research team based in Southern California found evidence that an earthquake can occur from a much deeper level than we had thought, more than 15 miles deep, placing the seismic event in the upper mantle of the Earth, not in the crust at all. A reminder for those of us who might need brushing up on our high school geography: the Earth's structure is made up of the crust, the mantle, the outer core, and the inner core. The crust is the solid, outer layer of the Earth, and the mantle is mostly solid, almost entirely solid rock unlike the liquid outer core, which is then followed by the solid innermost layer of the Earth, the inner core. Scientists had made the assumption that earthquakes can begin just 12 to 15 miles below the Earth's surface, as any deeper and we begin to make our way to the mantle. Due to the high temperatures and solid state of the mantle, researchers operated under the assumption that the seismic activity could not build up and develop in these conditions. These expectations all shifted, however, when a Caltech team used the most powerful seismic sensors available. The Caltech team from Pasadena, California, picked up small earthquakes using the previously mentioned seismic sensors as they moved across the Newport-Inglewood fault line further than the anticipated 15 miles, breaking the surface into the upper mantle. This seemingly small difference marks a significant discovery. This is a new, never-before-seen type of earthquake. So what does this mean? Earthquakes are devastating, homes are destroyed, lives taken, jobs lost. Though there seems to be only bad news to come. Scientists have predicted that this new type of earthquake means that future earthquakes can become even larger, leaving even more damage in their wake. One of the researchers, Jean-Paul Ampuero, explained, if earthquakes want to get big, one way of achieving that is by penetrating deep. He continues to elaborate that the fact that the earthquakes can penetrate the Earth deeper than we thought possible means that they could catch us off guard, getting larger than we would expect and bigger than we are prepared for. Since both the Newport-Inglewood fault line and the San Andreas fault line are the same category of fault, it is reasonable to assume that the longest fault line in California, San Andreas, stretching for 750 miles, is also capable of producing these deeper earthquakes. This research follows the 2012 earthquake that struck the Indian Ocean, near Sumatra, a huge earthquake clocking in at a staggering magnitude 8.6. Ampuero mentioned that this was the biggest earthquake of this type to have ever happened. This fault is known as the strike slip, which, again, much like Newport-Inglewood, is the same type as San Andreas. The team began to delve deeper into just how the 2012 Sumatra earthquake was able to happen, figuring out that these deeper quakes break into the mantle. So far, there are not many definitive answers. While scientists are guessing that these deep earthquakes will be much more dangerous and more extreme, there are others who say that this is all simply blown out of proportion, and the deep earthquakes may just be small and localized, not expanding or connecting with one another, and therefore leaving the surface somewhat undisturbed. If this is correct, it means we would see a series of tiny earthquakes, but never one big one. Ampuero said, "I wouldn't say that this is cause for alarm at this point. These are very interesting questions that we need to pursue. We don't yet know whereabouts in the planet these earthquakes can occur, whether they will play out in one large disastrous blow or lots of smaller, more manageable waves. For now, researchers continue to dig deeper, finding as much information as they can. Until then, we will have to wait and see just how these earthquakes begin to play out." Footprints suggest Neanderthals climbed a volcano. Would you go rambling up the side of a volcano? Well, whatever your answer is, it seems our ancient ancestors might have done just that. In southern Italy, there are a famous set of footprints moulded into the rock. Known as Ciampe del Diavolo, or Devil's Trail, folklore said that the devil himself left dozens of tracks that still exist to this day. Now, a paper published in 2020 might have the real answer. It turns out that the 67 markings of feet, hands, and legs could actually be some of the oldest human footprints on record. The prints, some of which head up the mountain rather than down, were made during a soft cover of ashfall following an eruption around 350,000 years ago. Researchers believe that the marks were made by 5 different people. There is hope that further investigation could help us ascertain more details such as weight, gender, and height. What we do know is that they were not members of our own Homo sapiens species. There are some clues. The features of these footprints, specifically the broad width of the hind part of the foot, along with the low rise of the arch, show striking similarities to remains found in the Cima de los Huesos, pit of bones. The pit of bones remains have been labelled as everything from Homo heidelbergensis to Neanderthal to Denisovan, and even back to Neanderthal again. If these volcanic footprints were made by Neanderthals, we can assume it was a gang of adults, at least. However, scientists aren't ready to set anything in stone. We have decided to keep the attribution to a specific species still pending, lead researcher Adolfo Panarello told New Scientists in January 2020. But what do you make of these discoveries? Be sure to let us know your thoughts in the comment section below and help us grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.